In this question, it asks you to sketch the graph of h of x, which is f plus g of x, given that f of x is x plus 1 and g of x is x squared. So these are the functions. Here, the purple one here, that's x plus 1, right? It has a y-intercept of 1 and a slope of 1. And then the x squared is this parabola, the one that's in yellow or orange there. If we want to do f plus g of x, we can look at a bunch of points like we did in the other one. But because this is, the other ones were like piecewise functions, a bunch of little parts of functions put together, so you didn't really get a pattern. Here we should be able to see a pattern. So I just chose x values between -2 and 2 to have a look at. So y1 is actually f of x, and y2 here in my table is g of x. And if we're trying to find f plus g of x, so this first value, that's going to be f of -2. And the next one is g of -2. And then f and g of -1 are there, f and g of 0, f and g of 1, and f and g of 2. And those can all be found from either the equation or the graph. So to find y3, which is what we're going to call h of x, all I need to do is add those values together. So they might be kind of hard to see from where you are, but the first one we have -1 and 4. So when I add those together, I'll get 3. And then I have 0 plus 1 is 1. 1 plus 0 is 1. 2 plus 1 is 3. And 3 plus 4 is 7. I get these values. So the ordered pairs are actually -2, 3. That's going to be 1 point. Let's see if we'll plot that. -2, 3. That's kind of big, but that's okay. -1, 1. So I'm taking the original x value and the new y value that we found. So -1, 1. And I have 0, 1, 1, 3, and 2, 7. So those red dots. I might want to look at a few more points to really get a good idea. But what general shape is that making, would you say? Yeah, it's it's going to be a parabola, right, when it's done? So it's going to go something like this. I'm not sure exactly yet, but let's have a look. Here are those points actually plotted, but we already did that. And then we may want to look at a couple more points. Probably like something in the middle here to get an idea of what actually happens, you know, where the vertex is. But there's the actual graph, that red line. And this one actually asks us to write an equation for h of x. So what is the equation of this red line? X squared plus x plus 1. Good. So did she figure that out by looking at the graph and finding the equation, or something else? Right. It's f of x plus g of x. So f of x is x plus 1. G of x is x squared. Add them together, and that's what you get. So all you need to do, actually, if it's asking you to find something like f plus g of x or f of x plus g of x, just take the f of x function, add the g of x function, and then simplify. We could do the same with a thing like this, where it's asking for f minus g of x. Instead of going through all that work of the table of values, finding all those points, if I want to know what f minus g of x is, it's going to be f of x, which is x plus 1, minus g of x, which is x squared. And so it's -x squared plus x plus 1, which is that red parabola on the graph. And you could easily find that graph just by typing into your calculator y equals negative x squared plus x plus 1. You don't need to go through that whole process of finding the points. If you're just asked for one particular point or 2 points, it's probably easier to do what we did before. Or if you have a graph like you had before that was like a piecewise, you know, a bunch of linear functions put together and you don't have an equation for it, then you're going to have to do that. But if it's a question like this, just use the functions, subtract them, and then use your calculator to graph. So here's the same two f and g functions, and it's asking us to find f times g of x. So I just put a dot there to mean multiply. I think in the other one I didn't put anything in between, but you know multiply could be a dot or nothing or an x. So f times g of x. Let's see what that's going to equal. You see what it looks like here? This red one? What kind of function is that? It's cubic, yeah. And it's because we're multiplying together f of x, which is linear, by g of x, which is quadratic. So h of x is going to be equal to f of x, which is x plus 1, multiplied by g of x, which is x squared. And when you expand that, that's x cubed plus x squared. So that's the function h of x. And it makes that red line that is a cubic function. If you didn't actually expand it out, you can see it's cubic, positive lead coefficient. It has a 0 at negative 1 and 0. And the 1 at 0 has a multiplicity of 2. So that's why it looks like that. There's the equation. But again, you could use your calculator to find it. And I think I have one more. F divided by g of x. So this one is going to be f of x, which is x plus 1, divided by g of x, which is x squared. And we can't really simplify that. And we don't know a lot yet about this type of function, but we are going to learn more about these rational functions in this unit. But it's these two red lines. And you can see that it does not exist at x equals 0. Anybody know why? You can't divide by 0. And 0 squared is 0, so you will have, when you're dividing, some non-permissible values that end up being asymptotes usually, or maybe points of discontinuity. But we'll talk lots more about that in another unit. For now, you need to be able to come up with this function and graph it.